In order for us to understand more about similarity and similar figures, I'm just going to review about how to write a percent and a fraction as a decimal. So 50%, to write it as a decimal, your decimal is right at the end of the number. So it's 50 and then the decimal. So to write a percent as a decimal, you need to move the decimal over to the left 2. So that turns it into 0.5. You can write it as 0.50 if you want, but 0.5 is the same. So 25%, my decimal's right here, I'm going to move it over 1, 2. So that's equal to 0.25. 6%, my decimal is, actually I'll write 6% right here. So my decimal is right here. So I'm going to move it back 1 and then back 1 more. So I need to hold the 0 in that place value in the tenths place. So this is 0.06. 10%, the decimal is right here, so I can write it as 0.10 or just 0.1. 120%, the decimal is right here, so I can move it 1, 2, so that's 1.2. You can also write fractions as decimals. So to write fractions as decimals, you can compare 1/2 with how many out of 100. Okay, because we can think of hundreds. So, or you can think of tenths. So 1/2 is equal to, if I multiply this by 50, I have to multiply the numerator, the top, by 50, so it's 50 hundredths, which can reduce to 5/10, so 0.5. So 1/4, you could write this as, how do I go from 4 to 100? Well, I have to multiply by 25. So the numerator, the top of the fraction, is going to be 25. So 25 hundredths is 0.25. If you're not sure how I go from here to here, I look at how many zeros are in my denominator, and that's how many decimal places it's going to be. So it's 0.25. So 1/10, you can think of it as 1/10 or a tenth, 0.1 as a decimal, or you could look at it as a 10 over 100, which reduces to 1/10 again. So as a decimal, it'd be 1 over, or 0.1. 3 hundredths is 0.03. Now, if all of these were scale factors, okay, if we're thinking about this as a scale factor, the numbers that are greater than 1, so if the number is greater than 1, it's going to be an enlargement. And if the number is less than 1, it's going to be a reduction. Now, synonyms for enlargement means a stretch. So enlarging is to stretch. Reduction is to shrink. So this would be a reduction, a shrink. This would be a reduction, a shrink, because it's less than 1. Reduction, shrink, reduction, shrink. Actually, all of these are reductions or shrinks because they're less than 1, besides this number right here. This would be an enlargement because it's greater than 1. So just to recap some vocabulary, similar figures is when one shape can become another after a resize. So a resize is, we're talking about enlargement and shrinking and reductions and stretching. And flips, flip is a rotation or a reflection. So if you have a smiley face with one side winking, if you flipped it over here, that's a reflection, the other side would be winking. A slide is to shift something, to move it right, left, up, down, or a turn is to rotate or pivot. So similar figures, same shape, same size, or different size. Corresponding parts, so we talked about this already, are in the angles, segments, and points in the same position. So the segment DA corresponds with HE. The segment DC corresponds with HG. So the segment corresponds with HG. You can also have angles that correspond. So angle C corresponds with angle G. And actually, what do you notice about if these are similar figures? Notice that these angles are going to be the same. The measures of the angles that correspond are going to be congruent. They're going to be the same measure. We also talked about rules. Okay, so if I'm looking at this is mug and zug, what was the rule to go from mug to zug? Well, if I look at here, the rule is double the width, double the height. So X has to deal with side to side. So X deals with width, and then Y goes up and down. So Y deals with the height. So I doubled the width and doubled the height. Now, you can actually list out all of the ordered pairs. If you know all of the ordered pairs for mug, what you do is you just have to double the X, double the Y to go from mug to zug. So double X, double Y, double X, double Y, double X, double Y. We have a pattern here. Same with we're talking about lug. So the rule for lug is 3xy. So what you're doing to go from mug to lug is you're tripling the width, because remember that X goes first. So triple the width and then keep the height the same. So that does not result in a similar figure because these two numbers are different. Now we look at bug. Okay, so the bug, if you look at the rule for mugwump, if you look at each one of these, you're multiplying the X and the Y by 3 every time. So from here to here by 3. Here to here, times 3, times 3, times 3. So since the rule is times 3 times 3, that's going to be enlargement. The scale factor, so it's an enlargement. The scale factor equals 3, and they are similar figures because each of these numbers, the 3 is the same. So it's 3 and 3 for both of them. It can't be 3 and 2 or 3 and 5. It's got to be the exact same. Okay, another thing I want you to notice too is look at these angles. So in these similar figures, we got right angles for bug and we got right angles for mug. These angles inside the noses are going to be the same. So similar figures have the same measures for their corresponding angles. Let's look at the rule for mug to glug. So glug is x3y, so the x doesn't change, so it's going to be the same width. But then the height, remember, y is up and down, y is the vertical axis. You're going to triple the height. So same width, triple the height. So that's not going to be similar. So there's not going to be a scale factor involved. So not similar. So let's talk about which rules would result in similar figures. So we need to look at if the number in front of x, are we multiplying the same number in front of x and y? So in this case, yes, both the numbers in front of x and y are the same. So these would be similar. So yes, similar. So the number in front of the x and y is a scale factor, so 0.3. And since 0.3 is less than 1, it's going to be reduced. And if you want to change it to a percent, you can say it's going to be 30% of the original one, because 0.3, if I write that as a percent, is 30%. This one, both of these numbers are not the same, so it's no, not similar. And they're both, the x is going to be half, so it's going to be half the width, and 60% of the height, or you could say 50% of the width, 60% of the height, so it's not going to be similar. And then these two are the same, so it's going to be yes, similar, and it's going to be an enlargement, and so it's going to be quadrupled. So quadruple means to multiply by 4. So you can write enlargement, and the scale factor is 4. This one's going to be yes, similar, because both of those numbers are the same. And then this one's going to be an enlargement, because 5 over 2 is greater than 1. This actually number, if you write it as a mixed number, is 2.5, and that's greater than 1. So the scale factor is going to be 2.5. Now how I write these rules are, I write the ordered pair xy transforms into 0.3x, 0.3y. So I put this arrow, means it's going through a transformation. It's going through a change. So I start out with the original xy, and I put an arrow to represent it's getting transformed. And all of these represent the rules of how it's happening. So maybe let's practice if I want to triple the width. What would you do? So if I triple the width, that's the x, so it's going to be 3x, and the y stays the same. So that's tripling the width. What about if I want to double the width and halve the height? What would that rule be? So double the width would be with the x, and halve is to take half of a number. So neither of these are going to result in a similar figure, because the numbers in front of x and y are not being multiplied by the same amount.